Hello everyone, welcome back to my video. This video is going to show you on Form 4 Chapter 6, another chapter from me called Coordinate Geometry. First, two parts in coordinate geometry is actually covered in modern maths. So to go through it, first we are going to deal with distance and locus, and equation of locus. Then followed by midpoint with second part, midpoint line segment and line segment. Third part would be the area of triangle. This is another method how to get the area of triangle when we're given a coordinate. The last part would be the gradient and forming of linear equation. That will be in a cover that will normally be tested in paper 2 in SPM. Now to start with, first of all, first part would be distance and forming of equation. So for distance A and B, if you're given two coordinate distance of A and B. Now imagine in a geometry, in a Cartesian coordinate, where this is my positive x direction and going up would be my positive y direction. The intersection is 0. If I were to have 2 points, say point A and point B. Now if I want to find out the distance between point A and point B, here, you can make use of theorem Pythagoras, the Pythagoras theorem, that first you need to find out what's the distance from here to here and then from here to here, whereby this is my capital Y value. If the distance here to here is capital Y, and my distance here to here is X value. Say if it's a 3, this is 4, eventually here you know the value would be your Y squared plus the X squared and the root, square root, the sum. 3, 4, and 5. Now if you are given a coordinate of A and B, then therefore the equation of distance of A and B will be therefore equals to a square root. In order to get y squared, that will be, it's given in a exam, but it's good to know it is y2 minus y1 squared. Now I want to change the sign. y2 subscript 2 minus y1 squared, that will be the y value squared, plus x2 minus x1 squared, and then the square root, that will be the distance. Now why is it y2 first? It's up to you. You may choose y1 first. You may start y1, and make sure if you start y1, you end with x1. Since I start with y2, so I'm going to use x2. You never use y2 here and then x1 here. That's wrong. They wouldn't get the answer. So that's basically what you learn in the first part, distance. Now next, you can learn locus and forming of locus equation. Now forming of locus equation, you need to know some basic on general equation form. What's the general equation or equation of general form? Where you would general form. This is in chapter 2. General form of an equation, that would be ax squared, this is a linear, ax plus bx, ax plus maybe by plus c will be equal to 0. It's true also in your scientific calculator. If you were to use a scientific calculator, the first a correspond to x value, b correspond to y value. Locus is similar to distance. Now, I'm going to show you an example. Says, example, you have a point A, maybe is 4 minus 3. And there is, or you were asked to find equation of the locus of a moving point P, x, y, such that its distance from this fixed point is always, meaning r is always 6 units. Now what does it mean with this kind of question that sounds like this? I mean, what does it mean is you have a point. You have a point, maybe A is 4 minus 3. You were asked to find equation, or maybe I will use, what's the equation that is around it, that always goes around it, that goes around this point, that make a radius, the radius is always 6. Any point around here is always 6, meaning it's a circle. So I would say this P x y that goes around this fixed point 4 minus 3. So this kind of question is rather straightforward. All you need to do is to apply the equation here, and you should get the answer. So to do that, that will be square root sum of y2, you may use this as my y2, so y minus negative 3. This minus is from the equation, this negative is from the coordinate squared, plus, black is what I want. Since I start with y2, I will end with x minus 4 squared, and then the square root is equals to 6. This is basically Pythagoras theorem. So you square root both sides, therefore square root both sides, simplify this, and therefore you should get an equation that looks like x squared plus y squared minus 8x plus 6y minus 11 is equal to 0. This is an equation of a locus. Therefore, this equation. So this is one variant. Another variant is when it is given in a ratio form. We'll show you next page. You are given 2 points. Example 2. Example 2. You were given 2 points. Point A, 2, 3. Point B, coordinate B, minus 4, 5. Now this is how you should answer in your answer sheets. You read from the question. Find the equation. Find the equation of locus, moving point P, x, y, such that its distance from 2 fixed points in the ratio AP to PB is equals to 1:3. To answer this, you need to illustrate in the diagram form maybe. 1 to 3, then you expect it to be, maybe I have a point A here. This is a point A. And then this one here, another side is my point B. Then my P, the moving point, should be somewhere in here. So that my distance here to here is always 1:3. Okay? 1 part to 3 parts. To solve this, AP to PB, you make use of what is given here. This is kind of like hint. So therefore, AP over PB, the distance ratio is 1:3. So the distance of AP to PB is 1:3. So all you need to do is to find what's the distance A to P, and to find what's the distance A to P, equate it, and you should solve it by making use of the previous equation here. By making use of this equation, you should solve this kind of question, and eventually you get the equation of Locus. To do that, here what you're going to do next is you cross multiply. Then there will be 3 square root distance of A to P. So I want to use my y as my y2. Start with y2. So it will be y minus 3 squared plus x minus 2 squared. This is a distance of AP. Should be equals to 1. So doesn't need to write 1. So square root of y minus 5 squared plus x. To be careful, this is equation minus. This is the coordinate minus. Maybe I'll use a square bracket to represent, to look at, so that you can see it better. Squared. You may use a calculator to solve it, but first of all, you need to square root both sides, so that you get here will be 9, and then wow, quite long. Y minus 3 squared plus x minus 2 squared, square bracket will be equals to y minus 5 squared. This is a crucial part, that's why I'm showing you this, plus 4 squared. Then you simplify it, multiply. This is a expansion, expand it, expand both sides, bring everything on the right, bring it over, rearrange, and you should get this. I mean, you should work on your side. If you are doing it, you may pause this video, and then you should give rise to an answer 8x squared plus 8y squared minus 44x minus 44y plus 76 equals 0. And this should be the answer for the Locus equation. You may pause it and then replay it. And I hope you get the concept for this part, which is our first part. Next part, we're going to learn let me refer back what you have seen. We have done this already. Maybe I'll use done. Then midpoint and line segment, which is quite simple because we have learned in modern maths. So for midpoint and line segment, This is part 2. Midpoint. Midpoint is rather straightforward because midpoint for any equation, for any coordinate, it means it is in the middle, at the middle. So if you have a point, if a line is always the best way. If I were to have a line, point A, point B, middle, maybe you want to balance it in the middle, maybe here. So the ratio is 1:1, so here will be half of a distance here and half of a distance here to get the point P, X, Y. So how I'm going to get this? This is the midpoint. It's defined as the midpoint, and midpoint equation would therefore be, says maybe midpoint I represent it with, maybe Z is my midpoint. Any symbol will do. Z will be therefore be the point A will be x of A plus x of B. The sum of x plus x by 2, and then y of A plus y of B by 2. And eventually this is the answer. You may go through the books, look for relevant questions. I'm sure you can handle this. Make sure this is XA, this is XB. Previous section is on distance. We use y2 minus y1. It's different, yeah? For midpoint is you sum all the x by 2, you sum all the y by 2, you get the coordinate. Because this is a coordinate. That's why this is the x coordinate, this is the y coordinate. Now next part would be a line segment. Now line segment will be slightly advanced, but if you follow my way of doing it, I'm sure you will remember how to do it, even 2 years later. If you are given a point A and point B, and there's another point, maybe here, point B, P, X, Y. And AP to PB ratio, come again, AP to PB ratio, A to P, P to B ratio is maybe M is to N ratio, M to N ratio. Okay. Now, in order to get what's the P coordinate, coordinate of P. Oh, I'm not supposed to use Z here because in the first part, because it's I define it as P, so I will stick with P. So P. Sorry, I make mistake too. So don't feel sorry if you make mistakes. It's okay to make mistakes. Now, the general equation, all you need to do is to sketch this diagram A and B, M to N. In order to get what is this, all you need to do is you cross multiply the ratio to across. You cross multiply them. What does it mean by cross multiply them? Now in A, you are going to have a coordinate called XA, YA. And coordinate B, you are going to have a coordinate X. This is coordinate B subscript YB. Now, in order to get the line segment of coordinate P, simply what you do, you M times the XB, cross multiply, N times XA. So it will be M number XB plus N XA divide by the sum M plus N number. Oh, sorry, I have not done yet. It's a coordinate. So the same goes with the y coordinate, comma. That will be M times YB plus n times xb. Oops, what am I doing? How can it be x? So these are the mistakes you will perform. One part y a over n plus n. Now I'm not going to show any example for this because it's rather straightforward. You may refer to any books, any workbooks, similar equation, and then try to work with it. It doesn't need to spend too much time on it. Sometimes they will ask you for any coordinate. They give you the ratio, look for coordinates, or they miss out one of the coordinate. They give you the line segment. Yeah, it is rather straightforward. So no example will be given. I mean, I'm not going to show any example. Otherwise, this video will be too long. I will focus more into the next part. What do we have next part? That would be, okay, so I'll assume this part to be done. Didn't show any example, but you may go through any workbook, check with the answer behind it. I'm sure you can get it. Now next part is called area of triangle. Now area of triangle, you do not confuse with the half times space times height. It's different this time round. You need to make use of the coordinate. There are a few ways to get area of triangles. Part 3. Part 3. Area of triangulars. Maybe equilateral triangle. Yeah, no. It's a triangle or quadrilateral, a square. Quadrilateral. Okay. Don't get frightened by those words. Words could be hard, but it's simple as ABC. Now, this part, important. When you are dealing with any questions later in your books, do remember, do something for yourself to make your life simple. In order to get area and you are given coordinate of A, I would show you only the triangle, but I'm sure you can do the quadrilateral because the concept is always the same. So let's say I have a coordinate A is x1, y1, B would be x2, y2, or C, x3, y3. One thing you need to do whenever you come across with this kind of question would be you need to arrange it. Arrange your coordinate. Arrange them in ascending order. You need to arrange it in ascending order. Meaning A, B, C, x3, this number should be towards the far right, whereas x1 should be over far left. In ascending order. Because otherwise you will have problem getting through the area. Now, this chapter, if you want to solve any question, is good to always sketch somewhere. No marks will be given, even if you sketch it, but it helps you. It helps you for sure to understand what's happening. So if you have a point A here, I would know this is my x1, y1. And A, B to form a triangle maybe is here, x2, y2, and maybe C here is x3, y3. So that I could have a triangle that looks like this, or maybe C could be on over the left hand side. Doesn't matter, but as long as in chronological order or in ascending order. Triangle wouldn't be so obvious, but in a quadrilateral, if it's a square or maybe it's equilateral or rectangle, then another side, another word text is you need to determine where is it. It's better to be in order, ascending order. So the area of ABC would therefore be 1 over 2, would still be the same in the matrix form. 2. If you were to start with x1, there will be x1. Maybe I'll write down x1, x2, x1. Oh, sorry, x1. Now, the next coordinate would be a counterclockwise. You need a diagram, that's why. In order to know what is the second coordinate, counterclockwise format. This is what you have to do. x1, x3, x2. It then stops here. You need to close it. Come back to x1. So this is x1. This is y1, y3, y2. This is y1. You arrange in this manner. That's why you need to sketch it. Where is the location? Counterclockwise. Make sure you come back to origin. And it's a good trick. The trick would be the key. Not a trick, but it's a key to know that the first point here, you try to use some small value or maybe close to 0. Small value possible, smallest possible value. Smallest value, 0 maybe. You place it here, then in the middle. Okay. So once you have this already, what can you do next is rather simple, really simple, because x1 times this number times this number, this number times this number, you sum them and then you subtract. Go to the left, you subtract the left number. And eventually an equation, you're able to solve it if you have a calculator, scientific calculator. That will be x1 y3 plus x3 y2 plus x2 y1. I'm sure you have learned this in your modern maths. The one to the left, that will be subtract x3 y1, subtract x2 y3, subtract x1 y2. Make sure you key it into your calculator accordingly. Use of a bracket, and remember to divide by 2 or times 0.5. Unit shouldn't be forgotten. Unit squared. You should write this in your exam. I'm not going to go through any exercise for this part as well because it is very heavy on calculation. I'm sure you work with a textbook. You should work with any textbooks. You're not supposed to go through this video and assume you know this. You need to practice on writing down this part and putting in a calculator and get the answer. You doesn't need to spend too long because I'm sure you have learned in your modern maths. That's why I would suggest you pay more attention to the last part of this video. You may download this video and then fast forward somewhere else, or fast forward to the point that you need. And if you need the soft copy, or if you don't know how to download this video, send me a text message. Give me a private message, and I will try to forward the soft copy to help you more. You will view it in any your phones, in your tablets these days, for your own pleasure, as long as it's not for commercial purpose. It's a non-commercial purpose, the video. Yeah, so you don't make any business from here. So third part would be done. No example even, but I'm sure you can do it. Any video downloaded from any of my OWC OpenCourseware series is not for commercial purpose. Shouldn't have any commercial value. It's for your own practice. I will be grateful if you share it with friends. Sharing is caring, after all. Now, last part would be gradient forming of linear equation. This part here is something challenging for newcomers, but as time goes by, you'll be quite good at it already, and didn't realize you are solving questions in paper 2 SPM. Now, part 4, last part of this video. I'll try to make my video as short as possible, but it will still be within 30 to 45 minutes. Part 4 will be gradient. Gradient and forming equation. For this part, there are some theory you need to cover. Otherwise, that would be too hard to learn this chapter. To get to score this chapter. So, first concept doesn't have a ruler. My writing device doesn't allow that to happen. So, x direction to the right, go up y direction. Now, at this point, you should have known that if any line that you have, any linear, if any line that's linear, there's no doubt for sure. Yeah, you have a point, maybe a point A and point B, point A, point B. Gradient would be just like the first part. Actually, first part is not really like here. This is a gradient. How much changes? The y to x. Changes of y, the ratio of changes of y to changes of x. What's the ratio? Changes. This is delta. I'll read this as delta. Delta means changes. Changes of y. How y changes from this value to this value. That would be y2 subtract y1. That is on the first part. And what's my changes of x? That would be x2 subtract with x1. You may ask, where does the x2, y2 comes from? Actually, it's here. If I were to have darker color, maybe. Say this is my x1, y1. This is my x2, y2 coordinate. If you drop it to here, drop it down to here. Therefore, this is my x1 value. This is my x2 value. Number is ascending. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If this is 8, this is 1. So the distance here to here is 8. Subtract 1. So you know it's 7. So if this is 1, if this were to be 8, the distance here would be 8 subtract 1. That would be, the distance here would be therefore 8 subtract 1. That would be therefore 7 unit. The same goes with the y. So therefore, by knowing this concept, therefore gradient of a point small m is equals to the changes of y2 minus y1 over x2 minus x1. Now for this equation, it doesn't need to arrange whether it's ascending order, descending order, any coordinate, as long as you stick with which one you define is x1, which one you define which one is x2, then eventually you should get the gradient. Or there are another equation that you should know, whereby in some cases in some cases, this is x, this is y. In some cases, or some instance, the line, when the line cut through, intersect at x and y, then your life is so much easy. It's much easier, because now that will be equals to negative is an equation to the y-intercept to the x-intercept. Okay? May look at it again. It's logic even if you apply to the first equation. In the case for here, if it were to be the coordinate here is A and the coordinate here is B, therefore my M is so much easy. M for gradient of this point would be negative B over A. Gradient go down from left to right is a negative. Obvious, right? Simple. Simple as that. Now this equation is limited to only when the interception, if you have intercept, this is ideal case. I mean, this is a special case. Some past year it came out also. I mean, it helps you as long as it intercept with x and y straight away. You doesn't need to make use of this equation. Doesn't need because it's rather long-winded. Then if you know how to find the gradient, next thing would be the ability to form an equation. Now in order to form equation, part 2, forming equation. In order to form equation, y equals to mx plus c, general equation for linear equation, Now, in order to have this linear equation, if you look at it carefully, you examine carefully, you will see that you need, in order to get an equation, you need to know what is m and what is c. Like last time, you substitute it and find what is c. But now in form 4, in SPM, thing gets much more advanced, meaning you're able to solve it within seconds. There are 3 possibilities. 1, you'll be given a coordinate x1, y1, and you are given a gradient and straight away you may apply a very, very useful equation, but it's derived from gradient. That would be your y minus y1 is equals to m times x minus x1. If you bring this term over, it's basically a gradient equation. This is a number, this is a number, this is the equation. Eventually you will form the equation y equals mx plus c. Right? So next, maybe I use another color to make it interesting. 2. Second method, you were given 2 coordinates only, x1, y1. Oops, system error. x1, y1 and x2, y2. You need to familiarize with unknown now. Given 2 coordinates, then all you need to do is, the concept behind it will be this. If it were to be a straight line, x, y, 0, of any coordinate, what happened? They make use of the gradient. The gradient of a point to here should be the same as the gradient to here, because it's a straight line after all. The gradient should be the same. It's parallel, the gradient should be the same. The gradient here, m1, are supposed to be the same as with the gradient here, m2. So therefore, they derive, not they derived. They summarize this. Therefore, the new equation, your linear equation, would be y minus y1 over x minus x1 is equals to the gradient here. Therefore, it's y2 minus y1 over x2 minus x1. So if you want to solve any question, make sure you list down the two coordinates, and then you just apply blindly y minus x1 equals to this number, subtract this number, subtract this number, and rearrange them. You should get your linear equation. You may try it with any exercise from any books. It works. It always works. Now the last one is very simple. Normally in paper 1, 2 marks question maybe. They were given only also a coordinate, but this time is the x-intercept, meaning one of the value is 0 in the coordinate, x-intercept and y-intercept. That would be very simple, because in this case all you need to do is you use x divided by, use the x-intercept number, a number, x-intercept number, plus your y over your y-intercept number. And you equate it to 1. Straight away you get the answer. You may try on any books. I'm sure it works. With any books that you have, it works all the time. In paper 2, also, there's something that you need to take note. Some terminologies. If you were to be perpendicular, meaning you have one line perpendicular with another line, intersection, meaning what does it tell? This point. What does it tell? That you have a gradient. Maybe this is my m1 gradient, and this is my m2 gradient. What is so special about perpendicular, this term, this word, as means about terminologies? What is so special is they want to tell you m1 times m2 is basically equals to -1. Now this is an important term in SPM, because in SPM it's always 90 degree. It's possible to be less than 90, but that is beyond the scope of our discussion. This line is, say, normal to it. This is tangent to a curve. Tangent would be another term. Tangent and normal. Of course, tangent you need to relate with some other things in Form 5 later, but for now it's good to know. For any curve, I'm just start with a curve. Any curve that you have, if it were to be tangent, so normally at a point P, if a line tangent to a curve, it means it touches at a point here only, at just one point. This is a tangent. Whereas normal would be 90 degree to the tangent line. This is the normal line. This is normal. So therefore, the gradient for tangent, this is, let's say, this is my tangent of normal M1, and this is tangent M2 line. Therefore, M1 times M2 goes to -1. This is something that you should know, and you should bear in mind. These are the keywords in order to solve all the questions behind it. Tangent, normal, perpendicular are the key to solve all the questions. Then, if they are cross at P, this point, if they cross, meaning at P, so it means they have a common point. It's simultaneous equation to solve it. The tangent line, normal line, you solve them. A common P, a common Y, then you should get the coordinate for P, and then you get the coordinate. That's all for this chapter. I hope you enjoyed this video. You may download it, rewind to the previous time, and I hope you learned something. You may download it, but again, if you want to download this, make sure it's for your own use only and it's not for commercial purpose. You may share with friends, and I'm not mean for your own use. You may share with friends, but not for any money. It should be shared with no condition, non-commercial purpose only. I hope you like my video. Do subscribe to my YouTube channel. You may share with your friends through a social network. And good day.